What is eutrophication? Eutrophication in Greek sense is eutrophia, meaning nourish well, or more precisely, hypertrophication is the enrichment of a water body with nutrients. This process induces growth of plants and algae and due to biomass load may result in oxygen depletion of a water. One example is the bloom or great increase of phytoplankton in a water body as a response to increased levels of nutrients. Eutrophication is generally induced by the discharge of phosphate containing detergent, fertilizer, or sewage into a aquatic system. There are types of eutrophication: the natural eutrophication and cultural eutrophication. Natural eutrophication process is very slow. It is occurring on geological timescales, although eutrophication is commonly caused by human activities. It can also be a natural process, particularly in lakes. Cultural eutrophication is the process that speeds up natural eutrophication because of human activities. The natural eutrophication. The paleolimnologist is now recognized that climate change, geology, and other external influences are critical in regulating the natural productivity of lakes. Some lakes also demonstrates the reverse process or metrophication, becoming less nutrients rich with time. The cultural eutrophication, due to some of reason like urbanization, land runoff is accelerated and more nutrients such as phosphates and nitrate are supplied to lakes and rivers and then to coastal estuaries and bays. Extra nutrients are also supplied by treatment plants, fertilizer, farms, as well as untreated sewage in many cities. Mechanism of eutrophication. Eutrophication arises from the oversupply of nutrients, which leads to overgrowth of plants and algae. After such organisms die, the bacterial degradation of their biomass consumes the oxygen in the water, thereby creating the state of hypoxia. The primary limiting factor for eutrophication is phosphate. Phosphorus is the necessary nutrient for plants to live and is the limiting factor for plant growth in many freshwater ecosystems. The sources of this excess phosphate are phosphates in detergent, industrial or domestic runoffs, and fertilizer emerging as the dominant contributors or auto-eutrophication. Sodium triphosphate, once a component of many detergents, was a major contributor to eutrophication. Enhanced growth of aquatic vegetation and algae blooms disrupts normal functioning of aquatic ecosystem, causing various problems. The depletion of oxygen level leads to the accumulation of nutrients unable to be decomposed. Slowly, the aquatic ecosystem is converted from aerobic to anaerobic condition, increasing the number of anaerobes, which apparently gives a pungent odor generally produced by methanogens and sulfur bacteria. Mechanism of eutrophication is the ability of phosphorus generally promotes excessive plant growth and decay. On the other hand, nitrogen in the form of nitrates also play a vital role in eutrophication process. Phosphate and nitrates adheres tightly to the soil, so it is mainly transported by leaking and erosion. Once translated to lakes, the extraction of phosphate becomes tough, hence, and difficulty of revising the effects of eutrophication. Sources of eutrophication. The point sources are directly attributable to one influence. In point source nutrients waste travels directly from source to water. Point source relatively easy to regulate. The non-point sources pollution is that which comes from diffused sources. Non-point sources are difficult to regulate and usually vary spatially and temporally. The example of point sources are wastewater effluent, municipal and industrial, runoff and leachate from waste disposal system, runoff from mines, oil fields, and seaward industrial sites, overflow of combined storm and sanitary sewers. The example of non-point sources are runoff from agriculture or irrigation, runoff from pasture and range, urban runoff from unsewered areas, septic tank leachate, other land activities generating contaminants. Effects of eutrophication. The effects of eutrophication are accumulation of organic and inorganic nutrients, conversion of aerobic environment to anaerobic, in turn alternating the appearance, odor of water body. Species diversity is altered, in turn overall aquatic ecosystem is affected. Growth of aquatic plants and algae reduces the light penetration and also increases the turbidity. Death of resident organisms takes place. Dew level decreases and sedimentation rate increases. Some example of eutrophication lakes. A view of Chalor Lake situated near Chimoga district, which is densely covered by aquatic weeds and algal blooms. The reason being the lake is surrounded by agricultural fields. The application of fertilizer in their leak into the lake causing hypertrophication. The second lake is Udaisagar Lake, situated around 13 kilometers in the east of Udaipur, revealed high phosphate content due to discharge of pollutants from surrounding phosphorate mines, chemical factors, distillery and domestic influence. This lake shows a green shade of algal bloom, witnessing eutrophication. The third lake is Dal is a lake in Srinagar, which is named the jewel in the crown of Kashmir. The lake is also an important source for commercial operation in fishing and water plant harvesting. The lake covers an area of 18 square kilometers, and it is part of a natural wetland which covers 21.1 square kilometers. Due to increasing urbanization, industrial discharge, and use of chemical fertilizer in the around the area has resulted in the pollution of the lake, causing eutrophication. Control of eutrophication. Sources of nitrogen and phosphorus need to be checked and prevented from entering the body. Timely removal or sediments of overgrown aquatic plants from the water bodies. Stimulation of algal food web. Chemicals such as alum, lime, sodium aluminate can be used to reduce the level of contamination. However, halting of eutrophication process is difficult but can be temporarily controlled to some extent.